So I'm going to try a different exercise in order to show you how you can take a piece of code that's written by somebody else and try to understand what's going on and then modify it in the way that you want to use it and produce your own output. So I'm opening a new script. Go to my MATLAB environment, opening a new script, which I will save under my Spirograph. That's what we are going to do. It's part of the assignment. And I'm going to paste into my window the code that I've taken from the materials. And it consists of the following components. So at the top, it creates a new figure environment by specifying figure to be equal figure 1. Then it creates an array with points in it, and the points are chosen from limits on the left-hand side 0 and up to the upper limit on the right-hand side 12 times pi. So if you remember that pi is a little bit larger than 3, so 12 times 3 is about 36. And between 0 and around 36, you put in as many points as fit with an interval of, and that's between colons now, 0.01 times pi. So pi is about 3, and then 0 times 0.1 times pi is about 0.03. So that's about the interval between points in that array. And if you specify this variable, I just copy it, paste it in my command window, make that a little bit bigger, and if I press enter, it's now been created, and I can check how many points are there. And I do so just interactively here in the command window by checking the length of points. Right? So length, and as an argument, the variable, which is points, I can find out from the answer that the answer is 1201. So it's 1201 points in that array. Now that we have those points, they are basically the basis of how many points do we want to plot. Well, it's 12,001 points that we want to plot. Now, axis just specifies the limits of the coordinate system of your graph. In this case, it will go from -5 to 5 on the horizontal axis, which needs to be specified first, followed by 2 numbers that give you the coordinates of the vertical axis, which is also from -5 to 5. The line hold on tells MATLAB to whatever you have plotted in your window figure 1, please keep it there when the next plot is made. So if you plot point by point, then all the previous points will remain in the figure and will not be erased. And this is achieved by putting hold to on. And then comes the for loop. So you know how for loop is started with a for and ended with an end. We then specify that the for loop goes through all the points that are within that array points by saying go from I to the amount of points that you have. So from 1 to 1201 points in steps. And that means you can use I as the index to call points in any array where you would like to. So what is done then? The points with the use of the running index I is then specified as to be taken from that array for the successive points, and it's assigned a variable called t. So within the for loop, each time I increases in value, take a point and call that t, and then using that t, you then calculate an x variable, which is the cosine of something plus 3 times the cosine of something else, and you specify a y variable accordingly, just using sine waves instead. So the mathematical functions I'm not going to explain. You can find them on Wikipedia if you look under Spirograph. Once you have an x coordinate and a y coordinate called x and y, you can plot them. So I have here in black the plot command that is going to be used, and so what happens is plotted x against y. So x comma y means take x on the horizontal axis, y on the vertical axis, use a specific marker, and if you look that up in the MATLAB help, it's actually a blue prism. So B stands for blue and P is an abbreviation for prism. So it will be blue prisms in this case. And if you look up the options that you have, of course, you can choose any marker that you would like for making the plot maybe more interesting than the one I'm doing now. And if you remember, by default, the marker size in MATLAB is always very small. So we choose the keyword marker size in quotes in order to modify that and set it in this case equal to 10, or I don't know, make it 12. The green line below is just a comment, so that will be ignored. And the final line of code that we have within the for loop is pause. And the length, I think, is in seconds, but whatever you put in there, it means that there will be a little break between MATLAB putting a point into that graph and then continuing with the for loop and calculating the next point. So that's all. There's nothing else to here. So let's see if that code runs. So by executing this piece of code, I can see that the spirograph is being plotted, and using that pause functionality, it's actually turned into a bit of an animation. So that's why we can sort of change the speed by changing the length of the pauses. And yes, it goes up and down, and then it closes the loop after 12 pi that we have incidentally chosen here. And so you can get that plot done. So I click that away. And finally, I just want to show you a very specific functionality that maybe is very complex for a beginner, but if somebody else has written it for you, you can just try if you can incorporate it into your code and use it, modify it if you like. So what that does is, you can maybe see that plot is assigned to P of I here. So that means the plot is created and that window is opened, and we can see those dots as they appear there, but pi is also a variable. Right? Just like we have points here, or x or y, pi, now that plot is also a variable, and it means any variable that you have in MATLAB, you can also modify it. So the next line then, set, is a function that modifies that plot. So you have it plotted, right? You have blue prisms, marker size 12, and x and y are the coordinates of a point that you have put in. You have kept all previously plotted point because hold is on. So what do you do to this then? Then the last point, which is P of I, can be accessed by putting P of I here, and you say P of I referring to the I where the loop is currently standing. Then picking the color, which means it's the color of the marker, so picking the marker which is currently blue, and then assigning it a new color. Why would we do that? Well, because we can pick maybe a different color because we don't like the color that there is, or we can replace it by something that actually changes over time, which is what we have done here. Namely, we have put in rand, rand, rand. First of all, why are there 3 numbers? MATLAB needs 3 numbers specified as RGB values in order to calculate the number that is actually plotted. So RGB means red, green, blue. So we have 1 number that specifies the red intensity, 1 number specifies green intensity, and the last number specifies the blue intensity. The final number is then calculated as a combination of those 3. If we put rand Don't know if you have seen the function rand. If you just type that in your command window, then rand produces a random number. That's why it's called rand. But the thing is, every time you call it, each time you specify rand and you run it, it will be a different number. So those numbers, although the variable here looks the same, it says rand, rand, rand. So that looks the same, but the number that is actually used to create the color will be different each time you call it. And it means we are plotting a number which we don't know beforehand, but which is randomly set, and thus will hopefully make our plot more colorful. If I just let the code run, then you can see, yes, now we have the same graph as before, but now every time the marker is put on the picture, it is replaced in its original blue form by a new value of RGB code, and therefore a new number is assigned. And if you think this is not very well visible, then let's make that marker size a little bit bigger and have it plot a proper brush stroke where you can see how every prism that is plotted now differs in color, and we get a nice colorful plot. And let's just wait until the loop is ended, and now that it's done, you can use save and save that to your computer as a picture file.